Okay, so this is a question about properties of substances, and this is a higher tier question. So we've got figure 4, this is figure 4, shows some properties of three substances A, B and C. A, B and C, right, deduce. So deduce means work out. Right, using the information in figure 4, the structure and bonding of substances A, B and C, explaining their properties in terms of their structure and bonding. Okay, so I'm hoping by this point you know there are three types of bond. So let's start off. Let's just give a very, very quick overview of them. So we've got ionic. Right, so ionic bonds have a high melting point. Right, sorry, we've got melting point and ability to conduct electricity. So they're the two things I'm going to talk about. So we've got the high melting point. Right, they also conduct electricity. They conduct electricity when molten. Well, we'll go through that when we go through the question in a moment, but essentially it's to do with the movement of the ions. The ions can move, right? Do not conduct, don't conduct electricity when solid, because the ions are in fixed position when solid. So that's what to remember about ionic bonds with high melting points. They conduct when molten and don't conduct when they're solid. Right, we've got covalent, right, between a non-metal and a non-metal. They have a very low melting point. Thing to remember, if you ever stuck, you can't remember, work out, if it's a gas at room temperature, it's got a low melting point. If it's solid at room temperature, it's got a high melting point. That's a general rough rule. So covalent bonds have a very low melting point because of the weak intermolecular forces. But we'll go through that when we have a go at the question. Right, and they do not conduct electricity. Do not conduct electricity. That's because the electrons again are shared. So although the intermolecular forces are weak, the actual covalent bond itself with the sharing of electrons is very strong. So there's no free electrons, so they can't move, they can't carry that charge. And then finally, we've got metallic, which have a high melting point. Again, if you think of most metals are solid at room temperature. They have a high melting point. Right, and they always conduct electricity. And they do conduct electricity, electricity, whether they're solid, whether they're molten, because if you remember the structure of metals, there's these positive ions surrounded by a sea of delocalized electrons. Okay, so there are three. Now let's go back and have a look at these. So let's go with substance A. Substance A has got a high melting point. You'll notice there's three melting points with a high melting point. It's a poor conductor when it's solid, and it's a good conductor when molten. So if we look at this, that would give us ionic. So substance A would be ionic bonding, because it's got a high melting point and conducts when molten. Tick. Does not conduct when solid. Right. Next one, substance B. Substance B's got a high melting point. It's a good conductor when it's solid, and it's a good conductor when it's molten. So of the remaining two, well, the only one left with a high melting point is the metallic one. And again, it's a good conductor of electricity. So substance B must be a metallic bond. And then just to cap it off, just to make sure, substance C, low melting point, covalent, low melting point, poor conductor when solid, poor conductor when molten, does not conduct electricity. So substance C must be covalent. Okay, now let's put that into some words over here as an answer. So, let's start off with A. So A is an ionic bond. Right. It has a high melting point. Because of strong electrostatic bonds. Right. I mean, we could go on there and say which take a lot of energy to break, but that's not what the question's asking for here. But if you have time, mention that. Right. It conducts electricity electricity when molten, because the ions, we need to specify its ions are free to move, so they can carry that charge. Right. It does not when solid, because the, again, ions are in a fixed position, so they are bonded tightly together. Fixed position. Okay, that's the longest answer of the three we're going to do, right? Because obviously we need to explain why it conducts when it's molten, and it doesn't conduct when it's solid. So it's quite a long answer for that one, for the ionic. Right, let's go back. So substance B, we've already established is metallic. Let's go do this. B is a metallic bond. Metallic bond. Right, it has a high melting point. A high melting point. So I'm just going to put MP. We know what we're talking about. High melting point due to strong bonds between the metal ions, so which are cations because they're positive. Remember they're positive ions, and the delocalized electrons, localized electrons. Okay, they are a good conductor. Because now this time, I know I've just spoken about because wrong as well, apologies. Because the electrons, so this is to do with electrons being able to move. Electrons are free to move, so it's this sea of delocalized electrons. So for current to flow, we need a negative charge to be able to move. So for this, it's electrons. It's the positive ions surrounded by this sea of delocalized electrons. So electrons are free to move. Right, and then our final one, C, is a covalent bond. Right, it has a low melting point, a low MP, right, due to weak intermolecular forces. So that is the forces between the molecules. So the actual covalent bond itself is very, very strong, but the bond between the different molecules is weak intermolecular forces. Right. It is a poor conductor. Because it's electrons we're talking about with covalence. Electrons are not free to move because they're bound, they're shared, are not free to move. So a slightly longer question there, but we see we're ticking off all the points as we go. So for each of them, it's a 6-mark question. We've said what the bond is, we've said the melting point and why it's got a high melting point, and we've said about conductivity, and then with metallic, again, why it's got a high melting point and why the conductivity is very, very good, right? And then we've said what the bond is for the covalent one, and we've said why it's got a low melting point and why it's also a poor conductor. Hope that's helpful, and I will see you again soon. Goodbye.